Welcome back. This time we're going to just talk about something I talked about a long time ago, the basics of soldering. Now, I came across this article, as you can see. This article was from AdaFruit on soldering. Now, we're going to go through this article a little bit because there were some things in there that I thought kind of dumb and extremely dumb. So, they outline a basic tool set and stuff like that. And first thing I looked at is they talk about soldering pencils. All I can say, you're going to do any sort of continuous soldering or whatever, the first two in this list, don't bother, right? It is literally a waste of time. Any of these cords you see plugged directly into the AC, no. You can get a very basic temperature controlled soldering pencil, kind of like the Hoke is down there, the Haku or whatever down here, Heko. But you can get cheaper ones, and they're on Amazon with a stand and a fine cord and stuff like that. What I've got. You can also go to AliExpress and shop around, and you can get a joint air gun slash soldering station for reasonably cheap. And when I say that, if you're not investing roughly $100 into to $125 into a good soldering station, you shouldn't be using these guys right here can because of the way the cords are, you can hurt yourself because they're so unmanageable. You'll inadvertently burn yourself or something like that when you're trying to move around and getting precise. And usually one of the problems on these is really cheap tips. Like the tips aren't very good, and it's very, very important when you do this. As I was going through this, yeah, they talk about these butane powered and battery, but I've seen some that actually work really, really well. Right? There's that USB one that's out there these days, something 100 or whatever, 101, that some people have. And they work like pencil like, they work really, really well. And I agree on this. Don't bother with this. This is for doing copper pipe and stuff like this. Um, as far as parts go, one of the things on this parts list here, this is all good and dandy, but I would add a couple more into here. I would add in the copper thingy to clean your tip. I would add in the tin pool. This thing is like just tin, and you stick your tip in, you tin your tip so that your tips are always nice and shiny, like so. And the solder. Now, this is one thing they don't talk about well, but it's the diameter of the solder that's key. So I happen to have two stands of solder here, and I'll bring them into view. So this is stand number one right here. Okay. This top one here is 0.75 millimeter, 6040 classical solder. It's just about big enough for anything you ever need. Anything bigger than this, and you'll find you get sputtering, you get a lot of rosin, that stuff that's in the solder. You just simply, it makes for blobs and stuff like this. Now, when you're doing the really fine stuff, this bottom row here is 0.5 millimeter. It's 6337. It's a more newer version of the top roll, but it's nice and fine, right? The only thing you'll find if you try to do big pads with it, you'll go through a lot of it, right? Now, I also found out basically, don't be afraid of going to some of the bigger suppliers in China and just getting this one. So what we have here is two. The blue roll here is your classical 0.8 millimeter lead tin, what they call 5545. It's very similar to the bottom roll in the other one. It's a slightly newer version. That's 6040. And the bottom roll is the what they call lead-free version. Now, even, as I said, 0.75 here and the 0.85 here, 0.8, you can see a slight difference in it. Like this is a little thicker to manipulate. I almost call this barely on the edge of to be used. Now, a roll like this out of China, shipped to you, will cost you about 15 bucks. Yeah, and it'll last forever. And you can get from these guys who make these rolls, you can get them in different diameters. You can get 0.5, 0.7, 0.8, even thicker, even thinner than 0.5. So take the time to actually invest. Just a sec, I need to move my soldering pencil and put this back. So now I've had both these rolls for a very, very long time. In fact, the date codes on these things are like 1999 or whatever. That's literally how little I actually put a dent in this rolls up to this time. And yes, a good set of side cutters and of this. Now, as I said, yeah, you can do the pad this. You can get these by the pack from AliExpress. You have to replace them. The only problem with them, when you clean your tip on them, they cool the tip down big time. And then your tip has to catch up. So if you don't have a reasonably good temperature controlled soldering station, and if you look to the little extra cam on the right, I'm going to turn it around and point at that. So I picked this guy up here for about $128, including the shipping. And I picked this particular one, which is the 852D++, which you can get from anywhere. This is happened to be by Sake, but the reason I picked it, it has analog controls on it. See those knobs? So if you look at the Heiko that was in the diagram here, we'll go right back to it. And we'll scroll back up to the Heiko. This one happens to be an analog version of the Heiko, but I don't even think you can get this from them anymore. Not this way. I think they've replaced this with the 2-button version. Like if we look, Heiko soldering station. Yeah, so you can see here, for example, up, down, it's touch controls. And even on some of the others, like the Weller here, right? But see, just this little thing is 169, right? This 173. This is all Amazon Canada. Let us look at, see, Amazon has the SAIKE and 852. See if we can find one in here. So 852 tips. Lots of tips. These is basically the same tip as Heiko does. No, we're all you can find their parts. Let me try 852D++. It looks like on the supplier list, at least on Amazon, they're not there anymore. So let's go to AliExpress. No, sorry, not Heiko, Seiko. SAIKO E, and then we want 852 D. There you go. So that's a similar station to what I have. Actually, that's practically my station right there. But see, and what you watch out for down here is the shipping. So this one's got a $34. You put this on here to make sure that you get American, or you put this here to make sure you get European, right? And you get all this stuff with it for your $125 plus shipping. It's not a bad deal. right? $34 to get it shipped to you, and then that is not a bad. But you can shop around. You could find these same stations all over the place, right? But I would personally avoid the ones with the touch controls on the front. So you get a base, you get all the stuff, you get all the tips, you get all these tools, right? The only thing I did on mine is I went back to AliExpress, and this cord right here, I bought a longer one and I just did the work and replaced the cord, right? And the only tricky part on that is technically it requires another soldering station to work it. I had originally my AOYO here. I think there's one here. AOYUE. So apparently I have their desoldering station. It works. I don't like the touch buttons. I really would prefer that it had the knobs like these guys right here. I wish it looked like this. This guy here, the 701A, is actually a like mine. It's a soldering station and everything. But I actually bought the very simple unit off Amazon. At the time, it cost me like $45 or whatever, $50. But I still have it. I consider it my backup soldering station. And the box is still up there. No, that's the air station, and that's the rework station. That's that one. And the oscilloscope box is up there. So, but let's go back to AdaFruit. So, watch out for that. I think they should have been more detailed on this. These are not bad, but they have a limit on the size they can hold. I would actually get a helping hands like I have the purple ones with the little arms on it, or the new one I just did on the last video. If you end up doing a lot of this with a solder sucker all the time, that is where a desoldering will help. If you end up doing a lot of that, you might as well invest in a desoldering station. It'll save you time and effort. The only thing is they're not generally cheap. So I can go back to AliExpress, for example. So we're looking at the AOs. So if we look at the 474A, this guy right here. So I got mine here in North America for about 160, I think it was. Right? And this is what I mean by touch controls. Just a sec. Apparently I'm not showing the correct thing. This one, no, this one right here. So I have the touch controls. I don't personally like them, right? But if you're going to do any of this, you get this. And you can get these spare parts that they show down here. The little cleaners, the little round things in the corner there. They're the filters in the back of the thing, right? So when you're sucking solder, it actually prevents it from going down the tubes, right? And then that little springy thing in the center, that's flexible. That's where the solder gets caught in. And you have to, when you use that, you have to clean it out frequently. Make sure you keep it clean. But you can see that RU has plenty of these things. It's just they're not very. So this is not a bad one. This is the same one I've got, the A plus one, and 191. But the problem, of course, is going to be shipping on this. See, that's ridiculous shipping, right? Considering that the other unit I just showed you, its shipping was $34, and this one's $133 for the same weight, right? You have to watch that. That's kind of like an ongoing eBay scam that happens, and sometimes happens on Amazon too. You get an item that looks cheap, but when you look at the shipping, it's an arm and a leg. And of course, yes, wick, whatever. So let's go to preparation. So they're using the Wellers. Very nice. And it's in Imperial because it says 701. Mine's in Celsius. And apparently, a lot of the ones I find that come out of AliExpress are actually metric. They're not in imperial. But I vaguely remember the manual describing how you can switch it around. There's something you can do on it that it lets you put it into metric. But as I said, if you wipe like that, you will cool the tip down and then heat it back up and then cool it back down, then heat it back up again. So it can be hard on the tip. I watched some other channels about this, and the general consensus is use the copper mesh that I showed you. This guy right here. Use this to clean. You can just get more pads of this. Like this one's getting full of solder. But you can buy this stuff on AliExpress dirt cheap. You can buy like 10 of them for a couple of bucks. Right? Tinning the tip. Now, see, this is where you generate a lot of smoke all the time from your solder. If you do that, this is why I have the tinning cup. So when they talk about tinning the thing, that's this tinning bin I have here that you can get. And I just keep it beside my thing, and I frequently dip the tip in it, wipe it off, and I keep the tip clean. Where they have the immobilized the joint here, I talked about this before, my personal choice for doing some of this stuff. You can do that, but this is where an extra tool helps. These are little copper alligator clips. You get them from DigiKey or Mauser or whatever. See? And you put it on your lead. So if you're doing a board like this, which I'm going to plan to do, and I need to put the legs in, like so, I can go like so, and hold the thing in place. So once I get one lead soldered, basically, I can take them off. They also double up as another purpose, and that is when you're doing things like diodes and transistors and stuff like that that could be vulnerable to heat. Well, guess what? These are really good as shunts. You put them on the leg on one side, you use it to hold it on the other side. Or you might have a 3-leg thing, and you might put on the one side of the board the alligator clip here because this is the lead you're going to solder, and then you put another one on the opposite side on this lead to hold the transistor in place, right? Maybe put another one there, and then you do the middle leg with that copper down there, shunts all the heat out of it and doesn't go into the transistor. And then you just keep moving the lower one to the next one, to the next one, and you complete all 3 legs of your transistor. Now, this is not too much of a problem when you have those 74 7412s, whatever those ones that are voltage regulators, right? Because they're meant for a lot of heat. But if you're doing like a 2N222, lots of twos, they can actually be fried just by you soldering them, because you held the soldering pencil too long, heat traveled up and went into the transistor and baked it. So investing in from DigiKey or something like that in a couple of bags of these, worth doing. So let's go back to our web article again. From this point on, it kind of gets a little bad. So I don't understand sometimes you look at this soldering pencil here. Look how garbagey it looks. Even my pencil doesn't look like this. Right? My pencil, I mean, it's a little dark where I don't solder with it, but this looks like it's right here. It's corroded, right? You look at mine. Sure, there's color change in the tip and stuff like that. You can see here, right? And a little bit here. But definitely my tip isn't corroded. This one in the website, where on earth they got this from, I don't know. But this tip looks like it's heavily corroded. Holy moly, right? And another thing they do here, look how, in relatively speaking, I haven't put mine on a magnifying glass, but oh, look how large the solder is. That looks like the same point 0.8 or point 0.9 millimeter stuff, right? I noticed too that when you get really cheap solder, like they give you the solder, it's really thick. Or you get those tubes with a rolled up piece in it that you're supposed to dispense. Generally, it's fairly thick solder. Now, a lot of circuit boards, right? We're getting to that picture in a moment. A lot of circuit boards, if you look at them, like this one here, they put a solder painting mask on all the exposed tracks and everything. You can see it, all this blue here, right? It's the same with this board that here I have in my hand, right? This. You're hard pressed to find the traces in here because it's all painted and sealed. The only thing exposed is the tin holes that you do, right? That's it. So I'm not sure what they're doing. Just a sec. I'm just gonna go into top cam here, properties, and lock off the zoom. Focus is auto. Wow, that's funky. Okay, well the light level's fine. Okay, for a moment there the zoom was going in and out. Let's go back to the web. So they start showing this stuff. This stuff here is perf board basically. Right here, this green stuff you're looking at, right? It's the prototype boards. It's like the white ones they give away when you buy so much at AdaFruit. This is an actual, looks like a circuit of some sort. This is more perf board. This looks like a pre-done board that someone's being busy putting all the parts on. But even on this one, you can see all the critical joints and everything like that. All the tracks are sealed by a sealant. Now, we come to this. Who in their right mind is soldering like this? Give me a bloody break. This is like the worst case scenario. Look at all the corrosion. It's no wonder anyone who solders on this is having trouble soldering, right? This is dirty. It is corroded. It is just utterly bad. This is literally the worst case scenario. And I think throwing this in will scare people off of soldering. They think this is what the when you make mistakes, it will happen. No. If the boards are clean like these, you should have no issue soldering. Like the one I just showed you, the LED matrix thing from AdaFruit. Any of these boards that are all, pre-done, where you just have to solder, no, they're not like this. This is just utterly stupid, right? Look at these joints. Now you can also tell in here too, potentially, some dry solder joints, like these ones right here where the cursor is, right? And then this guy here. Ideally what you're supposed to end up with when you do soldering, right, is it's a small shiny joint. That's especially true for the lead solder. The lead-free solder apparently is a little duller in color, I've seen, but the leaded solder makes for shiny joints. They did surface mount here. And again, if you're going to do this right here, get a smaller tip. This is where it's really helpful to have a tip collection. Just change the tip out so you have a more finer point. You can even go for the tip that has a slight bend in it so that you can, it almost looks like a hockey stick, right? And the other thing, when you're doing some of this stuff like this, they don't show it on the surface joint here, but when you're laying out some of these parts like this, it helps to do, if you're doing a chip, is to do the two corner pins, just tin them slightly, put your part on top, use your tweezers to hold the part down, and then heat very carefully those two pads so that the joints get soldered. Then your part's in place. Then you can go working on the rest of the legs. Right? Let's look at some of this stuff. So here is And I have to say, come on, guys, this does not. They could talk about wetting in here and stuff like this. Really, it means is how well the solder flows. And this is where I saw a picture of something where they were really bad at soldering. They show that all the time, all these joints are so much severe excessive. Here's more dirty and corrosion stuff on here, right? Or you look at this board. No one in their right mind would solder with this. Look at all the bare copper. It's all corroded. Wow. Right? And then we're back to this guy here again. Right? Now there was so they're gonna show did he show any actual soldering? Cannot remember on this common soldering problems. They had a picture somewhere. They were showing them using the pencil. Now, one thing when you're soldering that's kind of key is when you have. I'm just going to put this in backwards just to show. So you have the leads like this, right there. Okay, when you want to solder this, for example, you do not place the pencil on the same side you're pressing this piece of solder into, right? So in this case, I have my solder over here, solder, right? And let's pretend this blue is the pencil. And you're doing this. You don't put the pencil right here and then push the solder against the pencil. This is one of the reasons you get big bad solder. No, you put the pencil on the opposite side and the solder on this side, and as soon as it starts to melt, you can feed just enough and it'll flow like a little lake. Punk. And you should get this little dome effect. And then when you clip the leads close, voila, you're completed. This doesn't go that way, by the way, but that's the idea. So pencil on one side, solder on the other side, and you push against the heated leg. So your pencil's heating the pad and heating the leg at the simultaneously, and then the solder comes in and will start melting right away. Now, if you have trouble, all these solders have rosin in this core. It's really rare that you buy solder without rosin in the core, right? Then you dip into what not Collins Lab. There's a YouTube I watch who does classical tube electronics. Mr. something. What was it called again? YouTube subs. Let's see. Dr. Lewis Rosman's on it. Bond games. Whoops. YouTube subs. Electronics. Mr. Carlson's Lab. And he talked about this too. You go and get this little bottle. I just happened to pick this off of Amazon. And then you get, I have it in a bin, what they call clean free rosin. Like, I mean, you don't have to wash it away or anything. It's not going to corrode or whatever. And you put it in here and you just use this. And you basically, like so, a little, you put on your joint. So if you're doing, for example, surface mount, you just go. Now, Louis Rosman, he uses a gel. Like he has his tubes of this stuff, and sometimes he overdoes it. But if you watch him, he will put a big blob of lube around of this stuff around what he's working on with the air machine, and you see how easy it is for him to get parts off and put parts on, right? And no problem. Then they actually have an ultrasonic board washer where they clean the boards after the fact. But I like Mr. Carlson's approach with the little tube, the dispenser bottle, and you just dispense what you need into when you need some raw aided effect. Believe it or not, just a little bit of that stuff really helps you make joints. But the stuff that's in here should work just fine. Once it's started to melt, it'll easily go in. Now, this is where the temperature of your pencil comes into a critical factor, because when you put your pencil on large pads, you immediately are sucking the heat out of the tip of the pencil. You can actually watch this machine start really going to work on the LED on it. So there's an LED that indicates, you see that blinky blinky by the knob? Well, it's telling it's trying to bring this temp thing back to 349 Celsius, right? Now, the only difference between the lead-free and the lead is temperatures. One operates at a lesser temperature than the other, or more, and I can't remember what the lead-free recommended is, but I don't think it's 349. I think it's actually less. But if you do this correctly and you have your pencil correct, this should be easy as pie to do. You should not end up with all the stuff they're showing here. You should not end up with this. You should not end up with this. Definitely don't end up with these types of joints right here. Oh, come on. You don't end up with these joints. Definitely don't end up with big teardrops like this on your thing. Right? So like this. You should not end up with this. And you look at this. If you're at this stage of the... Why you fucking stop doing that, you stupid thing? Okay, when you see this, you're in trouble, right? This is really, really crapped out. This is how traces get lifted off the board. That's a sign, and they are kind of correct. It is too much heat. But it's also a sign that you're holding the pencil way too long on everything before you put solder on or anything. But I see stuff like this that looks like corrosion. This is definitely corrosion. Right? This stuff up here, holy crap, that is just plain dirty. Right? And this is a sign that the solder is taking too long to melt. And by the time it melts, you put too much into it. Right? Yeah, you look at this. You shouldn't have to have these beads, right? This should not be happening. Also, as I said, too thick of solder. Right? You shouldn't be having. Now, I've never actually seen this effect. Only when you're doing big power connectors and stuff that have big, fat, wide leads that you have to work your way around the lead to get every part of it soldered in. I've never seen it on a single straight lead going through a hole like that. That should not be happening. That almost looks like lead-free, and it's looking like the temperature's wrong on the tip. And that's why it didn't even flow properly. But yeah, there's some of the stuff they show here is like, this shouldn't happen. That's a sign you just keep fetting solder and it's just, and you don't really need that much. One thing, if you look at these holes in here. If you can see the sides of the holes when you're looking in, they're all pre-tinned. Now, that's another thing. When you have a double-sided circuit board, like it looks like these proto boards have this, right? When you put this push-through parts like that in and you start soldering, you actually need to hold the solder and keep it hot for a little longer than usual so the solder flows through the hole, literally to the other side. So it's a joint, but you don't need that much. And in fact, those types of joints, you'll see very little on the side you were soldering because it all got sucked into the hole. But literally, I think some of the worst pictures were something like these guys here with the circling out. This is all like corroded, and this is definitely a circuit board that something it got dirty somewhere. It was like exposed to air. Now, I don't know if you ever noticed this on maritime stuff when they 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 find silver on wrecks and stuff like that and other things. It's the silver's not silver; it's actually black, and the copper and bronze is all um, has a pate on it, like a greenish stuff on it. Well, both those are react to water and air, and they'll just corrode. It's one of the reasons they seal these circuit boards with sealant, so they look like these boards where the traces here are all covered in paint. It's to prevent this sort of thing right here to happen, right? But I look at this and I see no, this is you shouldn't be even seeing this at all these days. I mean, I remember as a kid seeing some stuff like this, right? But even I, as a kid, when I was first began soldering, easily passed not doing this, right? What other things do we have in here? This is a cool trick. The only thing you'll find out when you're soldering, ignore the notes about not doing this. This is a good way of actually soldering these pins on. So you stick them in the breadboard, then you stick the item on top, and then you do all your soldering. Down here, down there, and it works. Da, 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 da. Let's see, is there anything? Yeah, so personally, don't buy this. Anything plugging on the AC wall, you'll just end up getting another one down the road because you'll get fed up with it and you won't like it. I like the badge though. So here they do show the correct picture, but I saw another picture. It's just that this tip of this pencil is all dirty and corroded. To me, this is a sign the tip should be replaced. And how did they manage to get all that corrosion so far up? They really did. They shouldn't have had that. So I am actually going to do some soldering now because I want to prep. I want to prep this. I want to get it ready. And there's some other boards in here I want to get ready. And I need something from the top shelf here. No, it's not tequila. It is this bin. Now, I was debating whether to put these on into here, like so. Or I can do out of this bin. This is why I got this stuff. I can do this sort of approach. Like so. There we go. So I can do that. So I still have my pins down here to plug into the thing, but I have up here pass-through. Now, I was reading up on this. Only a couple of pins are actually used on here. All the rest are actually just pass-through. So if I do it the other way with this, right, then I cannot actually tap this to do something else. Let's say I wanted to put a other sensor on there or something like that. So I'm seriously tempted to do one of these boards this way and one of these boards that way. I have two of the boards, so that's easy enough to do. Some of the other boards I had, they would have me put it straight through the board like that. But I bought, where are they? I think it's this bag. Let's get one out. Right angle. So we're going to need some of those. And that will go back in here. And just put this here. So I hope I did a better explanation of what you have to watch out in some of these tutorials for on soldering. It's just, I don't know. To me, it seems some of the stuff is pretty bad. So we're going to do this. Now we need a breadboard. So I happen to have, now if I can read with my new improved glasses and my labels, yes. So we need to move this for a sec. I need this bin here. No, that's breadboard wires. I think they're under here. And why do I have this box? I can add that to over there. And the capture device. And the wireless keyboard. This one. So we have, ta-da, breadboards. So we just need a breadboard here for a sec. That should do the trick. If you're wondering about the little guys that are in there, all pre-done with a power supply and everything on them, that was actually a make project or something on one of those sites from the guy who does several books. Monk. Yes. It's a kit from him. So what we want to do on here is... So I have to find out which one's set. That's that set. And that's that set. So if we go like this... Yep, that's good. And we do this. So that means we need... I think it's that. We skip a hole, like so. And we put this and this on here, like so. Did I do it right? Yeah, I should have. No, I'm off by one. I think I'm off by one. Yeah, I am off by one. They are closer together. This is where a pokey tool helps. And it comes with that station. I got them with it. So let's put this down here. Let's try this again here. Still feels wrong, actually. I don't know why. They're actually off by a little bit. So let's do one set at a time. So we'll do the long set first. I might have to resort to the copper ones to do things. Right? And we need something underneath. No, that's too much. We need a little padding underneath here. Not too thick. What do we have here? A little bit of foam. I used to have some bag of putty. I don't have it. How about a battery? That'll do. We just want it level. So we only need to do a couple. So we tin, we clean, and okay, done. I have to put the rest of them in, of course. Whoops. That's not a good idea. I forgot about that. The only trouble is these grippy holes in here are very grippy. I better solder the rest on. Now, I need my support. Did I have that around here still? A sec. I've been thinking of getting a cordless microphone. So... Yes, I know I built that soldering station yesterday, but sometimes when I'm doing stuff like this, its problem is my eyesight. It doesn't allow me. So we are going to do the rest of these. And I can just take my glasses off to do this because I can't see it very well. There we go. Couple more to go. There. Clean the tip. Now let's pry this off. There we go. So there we go. And let's see. Put my glasses back on so I can actually see. Let's get the little cam out and look at this. Let's see. Yeah, like that. But you can see generally, really good joints. This camera's not as a good resolution as you'd want. That's the only problem. So that's one row, and we need to put in this row. So I'm finding I can't use that quite yet because just the way the holes are placed in here. So I'm going to use copper to hold some leads in place. Like so. Glasses again. Nice little domes. Don't need the copper anymore. We can complete this one. The only thing is I'm using my Weller stand and it's just the tube. The end of this is just slightly too small for it. Gets stuck in my thing. There we go. One side done. Now we need to do the other side. And the green thing. So, other side, like so. And again, borrow our copper here. If you're wondering why I'm sticking them straight up, that's just because I find it just makes the gravity work better. We need something under here too. There we go. Okay, so don't need the coppers anymore. On that joint. You can actually see as you heat up things, the solder just flows like water. There we go. All done. That leaves this section right here. And we probably don't need the copper for this. We just need to make sure that we're going to have to do a little pin straightening here in a moment. I think There we go. Clean. Let's have a look. Not bad. This one's a little off. But it should do for government work. We just have to, oops, not tweak so much. Now I have a dead Arduino board I use for this testing. Yep, no problem. See? Fits just fine. Put my glasses back on here. Now, AdaFruit said that on these particular boards, depending how you're powering, you might need the auxiliary little power thingy here, this green guy. So this goes into here. So we need a copper here. In this case, it's a pretty heavy item. So what we want to do is make sure it's not to go anywhere. Heavy, I mean, is the item's pretty heavy for a through hole. And it's a very big pin. Like so. Take that down and we do another one. Like so. And it's on. So this is ready for use. Oh, there is two others here, a DN and a D6. Wonder what they want with that. They didn't mention that in the diagram. So there's a D out and a D in. D in is tied to D6. So let's have a look at the Arduino. So you're supposed to put it in this way. Yes, SCL, SDA match. I wonder if they tie D out into one of the pins here. Like pin 5. Analog in and digital IO out. I'm wondering if this D6 over here is actually digital 6 over here. And D out, I don't know. Well, you can check this out with a multimeter. I won't do it at the moment, but I will have to probably do that just to verify what's going on. Otherwise, I might have to solder some to a pin here just to contact it. But supposedly, one of these guys here or here is also the D in. So you can daisy chain. The D out goes to the next board. Da 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 da. So that's that one kind of ready. So put that down. Now there were some other boards I wanted to work on. Yeah, in here. So let's have a looky at this. No, don't start hiccuping. Knife. I like this. There's a cut line there, but yeah, they sealed this bag really low down. So let's have a look. And they give us this little useless one. So I don't like the concept of this sticking out like this. So we are going to do this. Un, deux, trois. 3 of them. And 3 of them. And 3 of them. Just going to get in a bunch of 3s here. Yeah, when I first got these, I thought you had to cut them with a knife. I didn't know they were actually snap and breaks. Well, you learn something new all the time. Wow. 1 off, 3 on. Okay, there we go. Bunch of 3s. So what I'm going to do instead is I'm going to make right angle ones instead of that. So what we're going to do is going to put 2 on like this. And I'll bring back my little soldering stand here. And we turn this around. Whoops, that one fell out. Let's put it back in. Now, where's my little battery thing? It's a little on the thick side. I need something. Maybe this little bolt will do. I want some. No, that's too small. Maybe the battery will be good. What we want here is to make sure this doesn't go too crooked. Okay, so soldering. Tip. Okay. Yeah, that looks good. Solder the other 2 pins on each one. It is really tight to get between these LEDs. So, oops, I melted the LED. Okay. Do this one. Again, this is where, yeah, we melted the LED a little bit. I consider that kind of a bad design to do it that way, but like so. Okay, that's one. I'm going to do a few of them. Let's put that back in there. So that was a good one. So let's get the rest out of the bags. Here's another one. And another one of the trash can. Another one. Well, this is a bit different. A bit different. Interesting. Oh, this is really bad. So this one here is really bad. If you look, 3 holes here. It's under the frickin' LED. So we'll have to do this one differently. So in this case, what we're going to do is we're going to do this effect. So this one's still 3 holes through. So put this one aside for a sec because that one's weird. And this one. Okay, yes, sir. William, don't open the bag up really well. Oops. Okay, so this one out of the bag. Did we get that? Yeah, so it. Okay, so that's another one. And then the last one here on this one. Actually correctly sealed properly. Now, static bags like this, I'd actually save them. They're kind of useful. I just put them over here. So, we're going to need those, but we need the right angle one here. So these ones work really well with the right angle ones. We're just going to borrow this just a sec for help. And where's our little soldering station? And our watch battery here, just to give us some height balance. Okay, so now this is kind of where a little bit where I break my rule, because I don't want to damage the LED on this. So I have to be kind of awkward. And again, my glasses, gotta get them off. So there we go. It's another one done. Do another one. I need 2 of these. And another one over here. Like so. I probably don't need it as long as I get this. And just a little bit just to make the angle correct. As long as we get one lead done, the rest will just follow suit. There we go. There we go. It's another one. One more to go. This one here. So we need 2 more of these right angles. So let's see, this one over here. And this one down here. Okay, where's my little coin cell here to help me with the keeping more or less a 90-degree angle on those things. Okay, so here we go. This guy here. Damn, I melted that LED. Not good. Oh, this is a bad one. Just too frickin' close together. It's almost like I have to touch the top of the pin. There we go. Sure, William, just melt the USB camera wire. Put this back on. Yeah, that looks fine. A little downward bend, but that could be straightened out like that. But there we go. Those are those. Now we come to the troubling one. This one. So this one's a little bit trickier to do. We will use the straights, but we have to do a really weird approach to this. And I need probably my needle nose for this, because they're going to get hot. So what we want to do on these ones is, first of all, a little pre-tinning on these. Okay, like so. And then what we want to do, actually, like this is where the copper guys come into effect also. We can use the copper one. And this is where like so. Now we do the other one. So we get one leg on. Like so. And then we do the other legs first. There we go. So, if we do everything correctly and we didn't screw up, we have, and I can't even see on the screen what I'm doing. Ooh. But here we go. So, here we go. Like so. So, same idea. So one side's in, one side's out. Do they mark it? In, out. Okay, so you would control it from this side and you would, oh my. Whoever broke these apart did a very sloppy job. Let's just clean this up here. There we go. There we go. That's actually better. So we have that one, which is actually an alternate version. Now, I think I had some others I wanted to solder. So those were those ones. So let's have a look. In this one and this one, let's just check. I don't think there's any soldering involved in this one. No. So this one here is a fundayo. So this is actually, as I said, you plug it in and no USB port. So I'm going to have to probably put a programmer on this. So I would gather one of these sides here is in and out. So we've got DTR, ground, transmit, receive, VG, SCL, SDA. Okay. Then we got VN, ground, ground, ground. We have the ISP port. We have a switch here for terminal and header. Yeah, definitely this is one I'm going to have to look up. And then we have, yeah. So, pin 1. Don't know. So it could go this way. Or it could go the other way. We're going to have to find out. Okay, so this one is very special. This is going to take a little research first before we do anything. And then these guys here, they're the same as my other one. They're just spares. Here's the other soldering stuff I wanted to do. So, let's put this aside somewhere over here. So we have this little board, this little board, this little board, and we do have the other one of that. I'm just going to leave this for the moment. So we have 3 little boards to do. So this one, and they would have me put in this, or the other way around, this. Like so. I'm going to change this. So where's our little bin of right angles? we need another right angle strip. So out we come. In you go. So we need 1, 2, 3, 4, 5, 6 this time. So 1, 2, 3, 4, 5, 6. Here we go. And I think I am going to do it this way. So I'm going to get my little coppers out here. No, oh, come on. Up vertical, please. It's the other reason. The copper's actually technically heavy. Who would guess that a metal has weight to it? Okay, so we get our little thing here. And we put this down here. And all we need to do is get one. And we need, where's my little clock battery here? There it is. We need a little boost there. There we go. And maybe a little weight on that side. A little more weight. You just need to get one joint. So there, just enough. Done. Now, by the time I get to this little stub of solder, it's almost time to switch over to another roll. Oh, look, there's another one right here. So, off you go. So, there we go. So, the idea of this, of course, is... There we go. Ta-da. So, that is a sensor. So we have others here. So that was that one. And then in these bags, in this bag, come on. Whoops, out we go. And this one. So we got 4-pin ones. And again, I want to put right angle ones on here. So 4 pins. 1, 2, 3, 4. 1, 2, 3, 4. Like so. And again, we will do it from the bottom, like so. Oh, these are nice. The holes are just friction fit. I like that. Makes doing this a lot much easier. So off with the glasses for a sec. And this one here, friction fit. They're so light, actually. There we go. Done. So back to this guy here. Well, glasses back on again. So here we go. Ta-da! So we have BMP 180 and we have a BMP 280, I think, version. Now, there was one other board somewhere around here that we had to put together. That was a driver board for one of the LEDs. So we got... These guys are going to need edge connectors. These guys already have their things on it. These guys already have their things on it. This guy right here. So that was for, I bet you, I think it came with this guy right here. I think that's what this one came with. So this guy, let's open it up and have a look. So we have ULN 2803A. I'm not sure why they gave me this. Oh, that must go to that one. So, but this one here, they gave us, and I kind of agree with this one. This is kind of a breadboard into one thing. So let's put this over here and get our breadboard out. We can pull these off. Now that we're done, this is where this really helps out. So come on, boys and girls. There we go. We straight? Yes. So as you can see, this helps doing this. For the glasses. Okay, so notice how you heat this up and it just flows. Just right. I have the pencil at a perfect temperature for myself. Flows down the hole. We turn this around. We do the other side. And by the looks of it, we have an extra pin on every one of them. That's okay. We're going to trim that off. It's not hard to do. Okay, so we're done. So let's get this off the board. Like so. A little like so. There we go. Now, as you can see, we have an extra leg on here, so we're just going to play snap the leg off game. There we go. 1, 2. There we go. So there we go. So we have the controller for it. Okay, so this I'm pretty sure is to drive that one. I'm not 100% sure what you're supposed to do with it, but we'll find out, won't we? So I'm just going to put this with the LED. But I find it kind of funny though. I'm not 100% sure it's supposed to go with that one. I'm wondering if it's supposed to go with one of these. I know it doesn't go with these here. And this, I don't think so. So I'm not sure. I lost track of where that actually goes. Oops. And we have this one in here. The AdaFruit Neo Pixel. And then we have all these guys here. These are not the same. These all use Max chips. And these use Max chips. Do they actually have their legs on? Yes, they do. These are actually RGB. So, What do we have? And yeah. So I got this with one of the matrices. I was pretty sure it was this one here, but it doesn't seem to actually need it. I don't know. We'll find out. Actually, let's take that out of there. We have a little container with things like this. Nope, not that. That's all the STM stuff. So all the connectors. I thought I had a bin full of little guys. All different ones. Well, guess what? I guess I get to start a new bin for these guys. So I'll just put them over here. And we got all these. And this is where some of the bags I saved. Like this one. Oh, do I have a smaller one? Nope, I don't. Not at the moment. I know I do, but I don't know where I put it. So we are going to put all this into here. They're all spare parts. Into here, in the corner one. Yada, yada, yada. And then these are all scrap. This sort of small statics I don't really keep. Oh, there's another one in here. So I don't keep all those generally. Let's put them over there. Okay. And we'll put these into storage bin. So we have, of course, but did I have in here the power supplies? What's in here? No, these are the Raspberry Pi hats. No. I have some boxes, and they have actual power supplies in them. I'll have to find them. So they gave me this 3 wires. So we've got a D out and a D in. Yeah, so we care about this one, and they gave me a connector for it. And I actually have all those connectors, right? So what I really need to do all these eventually is pin them. Put pins on them. Try my pinning tool. So these are the flexible NeoPixels. Oops, a little bent on the corner there. Well, it's an interesting. We'll be playing with that maybe today. But I will play first before actually kind of doing a video, because I kind of feel embarrassed when I really screw up. So we have to find out where we need power for it. So I need to put pins on the end of these. Probably some of those Molex. No, those pinning kit I have up there. They have the pins in it. So I don't even know. Did I actually put pins into one? Yeah, no, that's the resistors and stuff. I can't remember. Did I put it in here? No. What I should do on here is put another 2-pin joint on here, so I have the connectors up there for it. I will do that later. But I think that's it for the moment. This is just a split on soldering and then examples of soldering. So hopefully people get a better idea than that instruction manual, because I think that instruction manual is a bit piss poor. AdaFruit could have done a better job on that, I think. So I will call it here, and this will be the end.